Hi everyone. Today we're going to be talking about graphing linear inequalities. So first let's just do a quick review on how to graph lines. Alright, so first let's review slope-intercept form. So remember, slope-intercept form is y equals mx plus b. So when we look at an equation, we have that equation y equals mx plus b. Our m is our slope, our b is our y-intercept. So in this equation, my slope is 7, my y-intercept is 1. When I look at this one, my slope is -6, and my y-intercept is -1. And when I look at this one, my slope is -1, and my y-intercept is 8. All right, let's take a look at this one. This one happens to be missing the b value. So my slope is -3/4, my y-intercept is 0, since there's nothing there. All right, now this one is a little different because it starts with x equals instead of y equals. This equation happens to be missing the y value. So this is where we pull on our good friend Vux. Okay? So Vux tells us that the slope is undefined, and it's a vertical line, which means it never crosses the y-axis, so it has no y-intercept. Right? This one comes back to that y equals, but we don't have the x value. So in this case, we bring in our friend Hoy. In this case, our slope is 0, and since it's a horizontal line, it crosses the y-axis at 4. So my slope is 0, my y-intercept is 4. Alright, so now let's review how we graph an actual line. So here we have an equation. I have a slope of 3 and a y-intercept of -1. Remember that our y-intercept is our starting point, so I'm going to start by graphing a point at -1. From there, I'm going to do my slope, which is rise over run. Since it's a 3, then I'm going to put that over 1, so up 3 over 1. It's positive, my line is going to go up and to the right. So I'm going to go up 3 over 1, up 3 over 1, and then I draw in my line. All right, let's do this one. All right, there's a hidden coefficient of x, it's 1. My y-intercept is 2. Okay, so once again, my y-intercept, b, is my starting point. So I start at 2. I have a slope of 1. It's positive, so my line goes up and to the right. So my rise is 1. I put it as a fraction over 1. So I'm going to go up 1 over 1. And I can keep following that pattern all the way to the end. And if I want to get points down this way, I just do the opposite, so down 1, left 1. And then I draw my line. Alright, so there's your review for graphing lines. We're going to use that skill in the next part of this lesson. Alright, so first, let's remember our inequality symbols. We've seen these already this year, and we've seen them in the past when we had to just graph inequalities in general, but now we're going to be talking about linear inequalities. So this is our less than symbol. In the past, when we graphed inequalities, we remember that the less than symbol meant an open circle. Well, in this case, since we're dealing with lines, instead of an open circle, we're going to say we have an open line. And we actually describe that as a dashed line. And then we're going to do some shading. So our shading, when it's less than, means we shade down or below the line. Okay? This is all going to be in relation to the y-intercept. Everything has to be, or the y value, everything has to be below the y value. All right? This is my greater than symbol. And so again, it would have been an open circle. So we're going to say an open line or a dashed line. And since it's greater than, we're going to shade up. And our equations are always y is greater than or y is less than. So again, when we shade up, it's because we're shading above the line, because everything above that line has a y value greater than the y value on that line. All right, this one is less than or equal to. This is where we had the the filled in circle, the closed circle. So when we're dealing with lines, we're going to deal with a solid line. Okay? And then less than, again, same as over here, means to shade down. Okay? And then greater than or equal to, all right? The equal to part means that it's going to be a solid line. The greater than part means, again, we're going to shade up. All right, so let's take a look at how we do this. All right, so these are just kind of some things to look at. We're going to come down and we're going to go ahead and graph this. So this one here, y is less than 3. Right away we should recognize that it's missing the x, so it's one of our special cases. This happens to be hoi. So it's a horizontal line that goes through the y-axis at 3. I'm going to look at my inequality sign, okay? And that inequality sign tells me that it is going to be a dashed line, okay, because it does not have the equal to sign under it. So it's a dashed line, and because it's less than, it tells me I'm going to shade down. So I'm going to start by graphing that dashed line. Oops. Let me get those out of the way. I'm going to start by graphing that dashed line. Okay. So it had a y-intercept of 3. There's my dashed line. Okay. And then I need to shade down. So everything is going, so I want to shade in the entire area below that line. Okay. So we're looking for all the y values that are less than 3. So every point that falls in here, okay, is less than 3. All right, so now we want to know, is this one here a solution? 3 comma negative 2. So I'm going to go over to 3 and then down to negative 2. Nope, it's not going to show up for me, so hold on. All right, so we're going to graph that one now. All right, so if I were to graph 3, negative 2, that's going to be right here. All right, so we want to determine, is that a solution to this inequality? Okay? And because it falls inside the shaded area, we say yes. Right? Yes, it is a solution. Oops. And ignore that because that one's wrong. Okay? It is a solution because the point falls in the shaded area. So when the point falls inside the shaded area, it is a solution to that inequality. Basically, we can pick any point inside this shaded area, substitute in for the x and y, and it will make that inequality true. So I'm going to delete that one out. Okay. If a point falls on a dashed line, it will not be a solution. If it falls on a solid line in an area that is touching the shaded area, then it is a solution. So that's just something to think about. All right, so now there's going to be some try on your own. So I'm going to go through and do each of the examples, and then you will go back and do all the try on your own. All right, so let's take a look at this one. We're going to identify our slope and our y-intercept. In this case, our slope is -1. Our y-intercept is +1. Now, before we go to graph that line, I'm going to graph my y-intercept, which was at +1. Okay. Now we're going to determine our line. So my symbol is greater than. There's no equal to, which means it's a dashed line. It's greater than, so that means I'm going to have to shade up. So I'm going to have a dashed line, and I'm going to shade up. All right, so let's get the rest of our points. So -1 means my line is going to go down and to the right. Down and to the right. Remember, whoops, I keep doing that. Let's get that out of the way. Down and to the right. So remember, if your slope comes out as a whole number, you just put a 1 under it and then use that rise over run. All right, so there's my points. Now I can graph my line. We said it was a dashed line, and then we want to shade up. So here's my shading up. All right, so now they want to know, is 3 comma 2 going to be a solution? So let's check. 3 comma 2, is that a solution? So I'm going to go to 1, 2, 3, up 2. We're going to put a point, and we would say, yes, it's a solution because it is inside the shaded area. Okay? It falls inside the shaded area. Okay? This will be another try on your own. I'll have you come back to those. All right, let's graph this one. Now this time, this equation's not in slope-intercept form. So first we need to put it into slope-intercept form. We want to get that y by itself, so I'm going to subtract 3/4 from both sides. When I do that, my 3/4 x cancels out on this side. And we are left with y is greater than or equal to negative 3/4 x plus 4. All right, our slope is negative 3/4, our y-intercept is 4. So let's go ahead and get all of our points on here. So my y-intercept is 4, right here. Whoops. Get that out of the way for now. All right, now I'm going to use my slope. It's negative, so my line goes down and to the right. So I'm going to go down 3, right 4. Okay. Now, when I go to draw my line, it is greater than or equal to. So the equal to part tells me that it's a solid line. Okay. So as soon as I see that line underneath, that means it's a solid line. Right. The greater than tells me that I'm going to shade up. So anything above that line should be shaded. Anything above that line will be a solution. So now if we want to check this point here, graph my circle, or should have that in there already. So negative 2 comma 1 falls right here. Okay, so if we want to check to see if that a solution, it's not inside my shaded area. So we would say no, the point is not in the shaded area. All right, let's come over here and let's look at word problems. All right, so we always want to underline important information, circle keywords, okay? Write your inequality, decide is it a dash or solid line. You can use the cover-up method to find the intercepts, and always try to eliminate wrong choices. You can use a test point to determine where to shade. Now this one here in particular, though, doesn't give us a whole lot of information. All right, so move that to the side for a second. All right, Greg has at most 10 hours of studies for his algebra and English exams. We're going to let X represent the number of hours he spends studying algebra and Y represent the number of hours he spends studying English. Which graph shows the possible amounts of time he can spend on each subject? All right, well, when I look at my graphs, I see that they all look almost the same. My numbers are exactly the same on the X and Y axes. My lines all seem to have the same slope. They all seem to hit the Y and X axes at the exact same point. The only differences between the lines are 2 of them are dashed, 2 are solid, 2 are shaded below the line, 2 are shaded above the line. So that's what we need to look for, is what kind of line are we dealing with and where is it shaded. All right, so the key word here that's going to help us out is at most, and that's going to help us determine which inequality symbol we need to use. Okay, so to determine what our inequality symbol should be, that at most, remember, means less than or equal to. So at most, that's the most something can be, but it could be less. All right, so let's write our equation, because that's the next thing we need to do. We know that X represents the number of hours spent studying algebra, and Y represents the number of hours he spends studying English. Right? He plans on studying at most 10 hours. So we can add together the number of hours that he spends studying algebra and the hours he spends studying English to write our equation. So the number of hours he spends studying algebra plus the number of hours he spends studying English will be at most 10 hours. All right, so to graph this, we can do a couple things. We could change the slope-intercept form, or we could do our cover-up method. Remember, our cover-up method means if I cover up one term, we see that x is going to equal 10. If I cover up the x, we see y is going to equal 10. And that's what we end up with here in both cases, or in all four. All right, so now, a couple little tricks to think about. And as far as shading goes, when an equation is written in standard form. So this is a note that you definitely want to write down. Okay? So when an equation is written in standard form, if y is positive, you shade based on the inequality symbol. If y is negative, you shade the opposite of what the inequality symbol indicates. So this is just kind of a key piece of information that you really need to store in your memory. Make sure you go back and study this, because this will help you out when you're looking at equations that are in standard form, and how would you graph them, and how would you determine their shading. So in this case, my y value is positive, so I'm going to shade based on that inequality symbol. Okay? My inequality symbol was less than or equal to. The equal to meant solid line, okay, which means I can eliminate b and d. The less than indicates that we shade down. Okay? So that eliminates c. So that means my answer in this one is A. All right, that leaves us with one last problem, which is also a try on your own. So at this point, I need you to go back and complete all your try on your owns, and I will have the answer key posted in Google Classroom next class. I'll see you then.